Hello, good afternoon class. Ang topic natin ngayon ay example ng stiffness matrix method for two-dimensional pin-jointed structures which is commonly known as truss. So, ang truss ay structural system wherein the members resist only axial forces such as tension and compression. So, ang displacement dito along X and Y direction only. Translation lang, no? Hindi kasama dito ang rotation. So kapag translation, so you have the U displacement and then the V displacement and wala siyang rotation or yung theta. Tapos this is 2D, so we only have coordinates X and Y. So ito ang ating first pattern. The una yung joint coordinates and then degrees of freedom, then loads and support. Also, ang characteristic ng stiffness matrix, it can solve determinate and indeterminate truss structures, pati compound trusses. Ang ibig sabihin ng compound trusses, yun yung may mga members na nag-i-intersect or nag-cross. And also, nagkakapag-solve din siya ng mga trusses na merong mga members na square sa loob. Okay? As long as stable pa rin siya. Okay, so going back to joint coordinates, ang unang assumption natin dito, dapat yung structure mo, yung figure mo, nasa positive axis. Yung points niya dapat wala sa negative coordinates. So lahat 0 going to the positive X and then 0 going to the positive Y. And then, sa degrees of freedom naman, susundan natin yung node numbering. Okay, so, figure should be in quadrant 1. Ito yung sinabi ko kanina, dapat nasa positive X and Y axis. Then, joint numbering should be in a wave-like pattern in the longer direction. This is in a sense na kung ito yung figure natin, so parang ang points mo or yung structure mo, ang longitudinal direction niya is along the x-axis. Okay, so mag-start tayo dito sa this point. This is point 1, point 2, point 3, point 4, point 5. So parang wave-like pattern siya. And then degree of freedom or DOF refers to joint displacements in the global XY direction. Okay, so X yan yung U and then Y direction, that is the V. The number of degrees of freedoms is equal to the size of the structural stiffness matrix. And then loads should be specified in global XY direction. Ang ibig sabihin naman nung number of degrees of freedom, this is the number of displacements. For example, etong figure natin, you have 7 displacements. So para ma-solve mo ito, kailangan mo ng 7 equations. Also, we have here 7 displacements or 7 unknowns. And then, ito yung ating first pattern. This includes the coordinates, the freedom, and then the loads, and then you have here the type of support. So ito ang ating basic figure. This is our first sample. This is a determinate truss. As I've said before, ang stiffness matrix, pwede ito sa determinate, indeterminate, and compound. But for now, ang sample natin ay determinate. Pero later on, magbibigay ako ng mga requirements na highly indeterminate. Okay? Baka possible na magbigay pa ako ng compound or complex truss. Pero, ang procedure niya, basically, parehas lang, ano? So, ito tayo. This point, this support is pin connected. So, kapag pin, ibig sabihin yan, wala siyang displacement sa X or U, at wala din siyang displacement sa Y or sa V displacement. And then, this is roller support. Ibig sabihin nito, pwede siyang mag-move along the X direction. Okay, so this is a U displacement, no? And then, etong point naman na ito, wala siyang support, walang kumokontra sa displacement, kaya pwede siyang mag-move along X and along Y. And then, same at this point, and then this point. Okay, so, start tayo sa node numbering. Let's take this as node 1, and then, since wave-like pattern tsaka longer direction, this would be node 1, node 2, node 3, node 4, node 5. Okay lang yan, ano? So, 1, 2, 3, 4, 5. Tapos, ang coordinates natin, ang ginamit ko dito ay millimeter para madaling mag-compute. Okay, so yung node 1, since this is at the origin, 0, 0 lang yan. Okay, 0 and then 0. Tapos, node 2, nasa gitna yan ng 3 meters. So, ang X ni node 2 ay 1,500. Tapos, ang kanyang Y, nasa 2,598.0762. Okay? So, yung 2,598.0762, i-plot nyo na lang yan sa AutoCAD. This is 3 meters. Okay? And then, this is 60 degrees, 60 degrees. Obviously, this is also 60 degrees. So, kung 3 meters yan, itong length niyang nito is also 3 meters. Kunin mo na lang yung height nitong triangle, that is 2,598.0762. So, I used here the sine cosine function, trigonometry. Okay, next, dito tayo ngayon sa node 3. So, this is nasa 4,500. And then, the height is 2,598.0762. Parehas lang sila. Sa node 4 naman, the x-coordinate is 3,000. And then, y is 0. Then, finally, node 5, the coordinate is 6,000 sa x. Y coordinate is 0. So, dito pa lang sa coordinates mo, dapat sigurado ka na. Bago ka mag-proceed sa freedom, double check mo muna itong coordinates. Okay? Ayan. See? Dito sa node 3. Node 3, that should be 4,500. Pero may pass ko, 1,500. Okay. Otherwise, kapag may mali dyan, magkakaroon ka ng mathematical error. Okay? Next, punta tayo ngayon sa freedom numbering. Dito, ang ginamit ko is letter D. D stands for displacement. Ang pattern ng numbering ng displacement is susundan mo yung lowest node number, ano? So, dito tayo sa node 1. Meron ka bang displacement sa node 1? Dito? Wala. Kasi, pin support yan. So, blanco mo lang yan. Okay? So, blank, then blank. And then, node 2, dito tayo sa node 2. Okay, dito. Support ba yan? Hindi. So, meron kang displacement along X and Y. So, that is U displacement and V displacement. Or let's term that as D1 and then D2. Okay? Ang beginning number dito is always the X displacement or the U displacement. And that is 1. Okay, so dito siya sa column U. Yan. And then, you have number 2 sa vertical displacement or the Y displacement. And then, dito tayo ngayon sa next node is 3. Dito. So, meron siyang 3 and 4. Meaning, it is free to move along the X direction and the vertical direction. 4. And then, node 4, hindi rin siya support. Kaya D5 and then D6. 5 and 6. And then at node 5, you have free to move along the X axis or X direction, and that is D7. Displacement 7. Pwede ba siyang mag-move pataas? Hindi, kasi it is a vertical support. Okay, kaya wala siyang displacement. So, tatanggalin ko na yung dash na yan. Next is, dito sa column ng support, pwede mo rin namang ilagay, i-describe, at node 1, this is pinned support. So, node 1, that is pinned support. And then, node 5 dito, this is roller X. Okay. Roller X. And then at nodes 2, 3, and 4, these are free. Okay? Or blanco mo lang yan. Ngayon, dito na tayo sa loads. The loads are in terms of kilonewton. Okay, next is dito sa sundan ulit natin yung node 1. Dito sa node 1, meron bang load ito? Wala. Sa load 2, meron bang load? Ayan. Meron kang 100 kilonewton. But you have to identify at what direction, di ba? So, this is Fy kasi this is vertical. And this is applied at node 2. So, dito tayo ngayon sa node 2. Under Fy, ang lalagay natin dyan ay negative 100 since it is downwards. And then, sa node 3, wala tayong load dito. Sa node 3 pala, meron dito, ano? You have 50. And this is in the X direction. And that is positive. So, maglalagay tayo dito ng 50. Sa node 4, wala. So, blanco-blanco lang yan. And then, node 5, at the support, wala rin. Okay, so, that's the first part. Now, let's go to the second part. This is about member incidence, properties, and the direction cosines. Before moving on, dito sa figure na yan, may sa numbering, nodes, and freedom dito. Ang squared numbers na yan, that pertains to the members. Okay, so this is member 1, member 2, member 3, member 4, member 5, member 6, and then member 7. Okay, so pwede mong pagbalik-balik ta rin yan actually. Okay? So, punta tayo ngayon sa element 1. Yan. Element 1. The end 1 is 2 tsaka 3. So, 2 and then 3. And then, sa element 2, the end nodes are 1 tsaka 4. Okay? So, yung end 1, pwede mong sabihin na ito yung start, tapos yung end 2, yan yung end, yung dulo. And then, dito tayo sa node 3, you have nodes 4 and 5. So, ang trick dito sa end 1 and 2, yung end 1 or yung start node, lagi yung smallest or least number. Okay? And then 4, you have 2 and 4. Nodes 2 and 4. And then 5, you have 3 and 5. And then 6, you have 3 and 4. And then last but not the least, 7, you have 1 and 2. And then the area, cross-sectional area, it says here all members are 450 mm squared, kaya lagay ko dyan 450. And then elasticity, this is steel, so this is 210,000 megapascal. And this is in terms of kilonewton per millimeter squared, kaya magiging 210 lang ito. Okay, dahil ito ay kilonewton, pero dito this is newton per millimeter squared. Okay, next you have here x2 minus x1, y2 minus y1, and then the length, and then the direction cosines. Ang purpose nitong x2, x1, tsaka y2, y1, para makuha mo lang yung hypotenuse, which is the length. Okay, so ganun lang kasimple yan. Itong x2 minus x1, so this is the difference in length along the x direction, and then y2 minus y1, that is the difference in length along the y direction or y axis, and then length, that is the hypotenuse. Okay, so x2 minus x1 simply means the x coordinate of node 2 of end 2 minus the x coordinate of end 1. Okay, so ulitin ko. X coordinate of end 2, ano yan? Ano ang x coordinate ng node 3? It is 4,500. Ayun. Okay? So that is 4,500 minus the x coordinate of end 1. And what is end 1? It is node 2. Ang kanyang x coordinate ay 1,500. Okay, next, y2 minus y1, that is the y coordinate of end 2, which is, what is y of node 3? 2598.0762 minus what is the y coordinate of end 1. Ang end 1 natin ay node 2, which is also 2598.0762. So that is 0. Okay? And then dito tayo ngayon sa element 2 and 3. So ang element 2, ito yon. Okay, element 3, ito yun. Tapos si element 1, yan yun. Etong x2 minus x1, this is literally the length. If the figure is along the horizontal, then obviously ang y2 minus y1 mo ay 0. So, it is a horizontal member. So, 2, 3, and 1, these are horizontal members. Kaya, ang length nila ay obviously 3 meters. Okay, so this is 3, this is 3, this also must be 3. Pero, solving pa rin natin sila mathematically. Okay? So, si node 2, yan. So, that is also 3,000 minus 0. And then, this is 0 minus 0. Tapos, si node 3 naman, si element 3, ayan, this is node 5 and node 4. That is also 6,000 minus 3,000. Okay? And then that is y 0 minus 0. Ngayon, dito tayo kay element 4. Ito na. What is the x2? That is 3,000 minus 1,500. Okay? And then element 4, y2 is equal to 0 minus 2598.0762. Okay, tapos kay element 5, yan. What is x of node 5? That is 6,000 minus x of node 3, 4,500. And then for node 5, what is y of node 5? 0 minus y of node 3, 2598.0762. Yeah. And then node 6, element 6. This is node 4 and node 3. The x is 3,000 minus 4,500. And then for element 6, y2 is 0 minus 2598.0762. Ayan. Then element 7, this is 1,500 minus 0. Tapos ang y2 minus y1 nya is 2598.0762 minus 0. Okay? Always double check your computations. Yan. Okay, so dito ako nagkamali. This should be 2598.0762 minus 0. Next, we now go for the length. The length is equal to the square root of 3,000 squared plus Ayan, y2 minus y1 and then squared mo rin yan. Oops, this should be squared. Yan. Next, I will just simply copy this. Paste mo lahat dyan. See? So, 3 meters lahat yan or 3,000 mm. This is the square root of x2 minus this is the sum of the squared of this and that. Now, let's go to the direction cosines. Ito yung una nating lecture, yung direction cosines. Okay, ito yung sample natin. Similar to this. Ayan. L is equal to cosine theta x. This is x2 minus x1 all over the length L. Okay. Let us compare this with our sample. Ayan, see? Yung member number ko naka-box. Tapos yung nodes naka-encircle siya. And then the displacement numbering you have U displacement and then V displacement. If you can relate this, eto yun, okay? This is the U displacement and then the V displacement. Yung U, yan yung horizontal, the V is the vertical displacement. Okay, class? So, ayan, V, vertical. And then, sa boundary conditions naman, kapag support mo ay pinned, yung U displacement mo ay 0 or di siya pwedeng mag-move along X, yung V displacement is also 0 or blanco lang, no? Ayan, walang laman, 0, 0. Ibig sabihin, this joint is pinned support. Yan siya, which is this. And then sa joint dito at this joint, the displacement at U kay U5, U sub 5 or the U displacement at node 5 is not 0. So ibig sabihin meron siyang displacement sa U. Kaya dito sa node 5 here, meron siyang displacement number 7. Yan, U displacement. Okay, so next, direction cosines. Ito yung member. Okay, so yan yung member. Ito rin yung member. So at node 1 or this is end 1, ano, meron kang X and Y coordinate. At node 2 or end 2, you have X and Y coordinate. Kapag space yan or 3-dimensional, you have X, Y, and Z coordinates. Okay, so next, what is small letter L and small letter M? Those are your direction cosines. So, ang small letter L, that is your x2 minus x1 all over the length. Okay, so as I've said before, parang right triangle lang yan, no? Ang x2 minus x1, yan yung horizontal length, yung y2 minus y1, yan yung vertical length, and capital L is the hypotenuse. Okay, so balik na tayo dito. So your L is simply equal to x2 minus x1 divided by your length na 3,000. And then your M is y2 minus y1, which is 0 divided by the length na 3,000. Okay? And then you simply copy these equations. Next, dito tayo ngayon sa AE all over L. Yang AE all over L na yan, ipakita ko lang sandali, is actually this taken from this equation. Ano? Yan o, AE all over L. Makikita mo yung AE all over L na yan dito sa matrix form. Ayan. Meron din siya dito sa element stiffness matrix. Ito yung linear system. Ayan. AE all over L. Okay? Take note na yung mga sinosolve natin ngayon, yung direction cosines, small l, tsaka yung letters M. Okay? L and M. Tapos, yan yung mga displacements. U1, V1, U2, V2. Then, AE all over L, yan yung sinosolve natin sa Excel. Okay? So, actually, yung ina-assemble natin ngayon, itong constants nung augmented matrix. Dahil, ito yung sosolvin natin, yung displacements. Yung F1x, F1y, F2x, F2y, ito yung mga loads. Okay, so let me relate. Ayan. Itong column na ito, F1x, F1y, ito yung loads. Okay? Yan. Tapos, itong mga this square matrix. By the way, ang tawag dito sa matrix na ito, augmented matrix. This is the matrix form of this linear system. Okay? Yan. Ang unknowns natin dito yung U, V displacements. Ito, na-solve na natin yan. Yan yung direction cosines. Tapos, this is given. Then, these are the forces. These are also given. So, as I've said before, ilang equations ang kailangan natin. That also depends on your number of unknowns. Okay? Next, let's continue. So, dito na tayo ngayon sa AE all over L. So, this is simply equal to the product of area 450 times elasticity. Click mo lang yan. Close parenthesis. Divided by this length. Okay? Ayan. So, double click ko lang yan. Ayan. D24 refers to this area. This is cell column D, row 24. Ayan. Yung red naman na yan, E24. This is column E, row 24. Ayan. Tapos yung H24 refers to your length. Column H, row 24. Ayan siya. And we simply copy that, paste it here. Okay, next is dito na tayo ngayon sa direction cosines times AE all over L. Okay, so ulitin natin ito. Ang sosolvin natin ngayon, itong nasa loob na ng square matrix na yan. Take note, you have LM such as this. Ayan. You have L squared. You have M squared. Ayun. And then negative LM. Ayan siya. Tapos negative L squared. Ito. And then negative M squared. Ayan. And then, we will multiply it with AE all over L. Okay? Ayan. Ayan siya. Kasi naka-factor out na yan dito sa labas. So, this is simply equal to L. Click mo lang yan. Times M times AE all over L. That's it. And then, ito naman equal to L times this. Tapos, ito namang M squared, this is equal to M times AE all over L. And then, ito, negative LM squared, all I have to do is to negative, yan, tapos click ko lang ito. It's that simple. Ito naman, equal to, lagay ko yung negative dyan, and then click ko ito. Tapos ito naman equal to negative, tapos i-click ko itong M squared. And then I will simply copy this, paste it here. Okay, so that ends part 2. So let us review yung part 1, that is the joint coordinates, ito, and then the degrees of freedom, yan, tapos loads, ito, and then the support, yan. Then for part 2, you have the member incidence, ito, tapos properties, which are this one, and then the direction cosines, which are this. And then, ito na ngayon yung sinold natin lately, multiplying it with AE all over L. Now, let us go to part 3. I-assemble na natin ngayon yung element stiffness matrix, which is sa lecture natin. Ito yon. Okay? So, ito yung i-assemble natin. And remember that this column refers to your forces. And then, this refers to the direction cosines multiplied by A all over L. And then, you have here the displacements. Doon sa Excel, nagawa na natin yan kanina. Sa part 1, part 2. Ayan, yung direction cosines, ano? Tapos, yung forces. Ito. Tapos, yung displacements or freedom. Yung D1, this is D1, D2, D3, D4, D5, D6, D7. Okay, let us change this to D1 para hindi tayo malito. D2, D3, D4, D5, D6, and then this is D7. Okay, so remember that. And then dito naman yung ating figure, babalikan natin yan. Okay, so babalik tayo dito. And we start with element 1. So this is element 1. It is concerned with node 2 tsaka node 3. Node 2 being the end 1, and then node 3 being the end 2. Tapos ang displacements niya, you have D1, D2, then D3 tsaka D4. Okay, so I will copy this for now. and then paste ko dito. Yan. Tapos yung ating lecture, eto lecture ko noon natin before, so kinopy ko yan, and then ipinaste ko rin dito. Ayan siya, para hindi tayo mawawala. And then i-isolate natin itong D1, which is eto, ano, eto siya ngayon. Okay, ayan, eto si element 1. Remember na naka box siya. So element, this refers to element 1. This is node 2 or end 1. This is node 3 or this is end 2. And then displacements D1, D2, D3, D4. And then we will assemble the element stiffness matrix. Ito ang assemblein natin. So yung first column matrix, ito refers to your forces. Ito yon, ano? This is, let's say, F1x, then F1y, F2x, and then F2y, something like that. Tapos itong box na yan, ito yon. Then this box refers to your U1 V1, U2 V2, U1 V1, U2, then V2. Okay, so something like that. Tapos yung LM kukunin natin dito sa ating yung sinolve natin kanina, no? Nandito yan sa part 1, part 2. LM, L square, M squared, which is this one. LM, L square, M squared. Negative LM, negative, yan. Which is ito. So, kopyahin ko lang yan. This refers to element 1. Yan. Then, ito yung element 2. Ito naman ang kokopyahin mo mamaya. Okay? This row. Ayan. So, for now, let us copy this. Copy the values. And then, paste ko dito. So, right click and then paste values. Ayan yun. Okay, so dinelete ko muna yung mga nandito. Hindi muna natin kailangan yan. So, balik tayo dito. Yung L squared equal to, ayan, 31.5. Tapos dito sa second box, LM, that is equal to, click mo lang yan. Then dito negative L squared, dito natin ilalagay equal to, yan, negative 31.5. Tapos for this box, ito yung negative LM, okay? So, equal to, i-click ko lang, yan. Then, dito na tayo sa second row. Ang ina-assemble natin ngayon, yan. Okay? So, highlight ko yan. Yan ang ina-assemble natin. Next, sa second row, refers to this. Yan. So, ito ang i-assemble natin ngayon sa second row. So, that is equal to LM. Click mo lang yan. Then, this is M squared. Yun. Click ko dyan. Tapos, this is negative LM. And then, this is negative M squared. Ayun. Dito tayo ngayon sa third row. Okay. Which is this. Then, this is negative L squared equal to, click ko dun. Then, this is negative LM. Yan. Then, this is L squared. Then, this is LM. Ayan. Finally, dito tayo ngayon sa fourth row ng coefficient matrix. This is negative LM. Tapos, negative M squared. Then this is LM. Then finally, M squared. Yan. Next is, dito tayo ngayon sa F1x, F1y, F2x, tsaka F2y. Skip muna natin ito. Let us now go to the displacements dito. U1, V1, U2, V2. Yung subscript na 1 tsaka V1 refers to this displacement. So going back to the element stiffness matrix for 2D pin jointed structures, yung previous lecture natin, ito yun, ano? So this is N1, this is N2, this is U1, V1, U2, and then V2. Yan yun. But, what is N1? So, this refers to node 2, and U2, V2 refers to node 3. Okay? So, this is node 2. Oops. This also node 2. Then, node 3. Then, this is also node 3. Tapos, dito tayo ngayon sa node 2. Yung U1 natin, that refers to your D1 displacement or the horizontal displacement. And then yung V1 refers to the vertical displacement at node 2, which is D2. And then, ito naman, this is the horizontal displacement at, or this is now your D3. Okay? And then, this is the vertical displacement. This is now D4. Remember that, sa stiffness matrix or Hooke's law, kapag merong displacement, meron siyang external force. Okay? Or meron siyang internal force. Okay? Yung internal forces na yan, yan yung actual forces na nasa loob, tapos yung external force, yan din yung mga loads. Okay? This time, eto, kukunin natin yan sa mga external forces o kaya yung mga tinatawag natin na loads. Okay? So, yung numbering nito, this follows the numbering of your displacements. So, this now becomes F1. Tanggalin na natin yung Y. This becomes now F2. Then, F3. Then, this is F4. So, this is your element 1, or this is known as your element stiffness matrix for element 1. Ngayon, assemble na natin yung para sa element 2. So, first, I will copy this. paste ko lang dyan sa baba. And then, habang kinopya ko ito, pinaste ko dito, sinusundan din niya yung equations o yung mga links. For example, itong 31.5, nakalink siya dito sa L squared. Dito, nakalink pa rin siya dito. So, all I have to do now is to change this. Okay, this is element 2. Then, palitan ko lang yan. This now refers to, ayan. Okay, so this is, I will copy this again for my element 3. And then we have 4 elements. Remember that, okay? Element 4, element 5, 6, and then 7. Okay, 7, 6, 5, 4, then 3. Mahirap solving to sa calculator, pero pwede kung may matrix capability yung calculator mo. Tsaka yung calculator nasa 6x6 lang ang kaya nun. Okay, dito pa lang sa stiffness matrix natin, yung element nasa 4x4 na. Pero we have 7 displacement, kaya abot din ng 7x7 yung matrix natin. So, hindi kaya ng calculator yung 7x7. Okay, so punta na tayo ngayon kay element 2. So, balik tayo dito. Kokopyahin ko ito sa under element 2. Yan. Copy ko siya. Control C. Tapos, dito kay element 2. Paste values. Okay? Yan. Paste values. Automatic, may ilalagay na dito yun. And then, so para hindi tayo maguluhan, coveran ko lang muna ito. Yan. So, balik tayo dito kay element 2. Yan. So, si element 2, eto siya. Take note, si element 2, merong pinned support dito sa node 1. And then, you have free end dito sa node 4. Kaya dito kay node 1, wala kang displacement. So, this is 0, 0. Unahin muna natin si displacement. This refers to node 1. This is also node 1. Then you have node 4 and then node 4. Okay? Yung first two lines or two rows, okay? Yan, first row, then second row, refers to your end 1 or your start node o kaya yung node number na minimum. Tapos, next higher node yung third row tsaka fourth row. Okay? Yan. So, this is node 4. Ayun, sa node 1, meron ba tayong displacement? Wala. So, 0, 0 lang yan or blanco-blanco. Dito naman, you have D5 and then D6. So, that is D5 tsaka D6. And then, as I've said before, kopyahin mo lang yung subscript. So, this is now F5 and then F6. Okay? So, ganun lang kadali. Next, delete ko na yan. Punta tayo ngayon kay element 3. So, kay element 3, eto siya. Yan yung mga kinopy-copy paste ko kanina, ano? Ayan. Tapos, nasan si element 3? Ayan. So, copy ko muna si direction cosines. Ito siya, element 3. Paste values. Ayan. So, automatic fill up na yan. And then, this is node 4. The start node or end one, this is node 4. This is node 5. Then, node 5. Sa node 4, you have the U displacement or X displacement, that is D5. And then, the vertical displacement, D6. And then at node 5, you have horizontal displacement, D7. And then the vertical displacement at node 5 is wala, or that is 0. Then, balik tayo dito, you just copy the subscript or displacement numbering. So, this is F5, F6, and then F7. Okay, so ganyan lang kadali. Punta na tayo ngayon kay element 4. Yan. So, si element 4, copyin ko to. Paste values. Yan. Oops, nagkaroon na siya ng mga numbers. So, this is node 2. Okay? N2. Then this is N2. Then this is node 4. Okay? Then this is the horizontal displacement at node 2, which happens to be D1. Okay. Paano ko kinuha yung figure na yan? Galing yan dito sa ating main figure. Nasa part 1. Yan. This is node or element number 4. Ito yun. Okay? Ayan, si element number 4. Ito. So, si node 2, meron siyang displacement na D1, D2. Si node 4, meron siyang displacement na D5 and D6. This is D5, sorry. Naputol yan, okay? This is D5. So, kay node 2, you have D1 and then D2. And then node 4, you have D5 and then D6. So, let's follow the numbering. This becomes now F1, F2, F5, and then F6. And then, this time, papakita ko sa inyo yung parang shortcut na. So, yung element 5, and then 6, and then element 7. Okay, so, I copied these direction cosines here. Ayan. This is 5, and then 6, and then 7. Then paste as values dito, 5, 6, and then 7. Tapos, dito tayo ngayon kay element 5. Ang una natin gagawin yung displacement numbering. So, dito na tayo kagad kay element 5. Kunin mo yung lowest node number. So, that is node 3. And, anong numbering yan? D3 tsaka D4. Sulat mo dito ngayon, D3, D4. Tapos, susunod ay D7, horizontal. So, this is now D7. And then, blanco yan. So, copy the subscript numbering, F3, F4, and then F7. Tapos, element 6, dito na tayo. So, this is, ang node numbering niya ay 3 and 4. Okay? Kay node 3, you have D3, D4. Yan. So, D3, D4. And then, you have D5, D6. Node 4, no? So, this is D5, then D6. So, kopyahan mo yan. F3, F4, F5, F6. Finally, kay element 7, you have node 1 and node 2. So, kay node 1, wala. So, blanco, blanco. Kay node 2, you have D1 and D2. Then, you follow. This is blanco, blanco. You have F1 and F2. Next is, gawa tayo ng bagong worksheet. So, i-click ko lang itong plus. Ang gagawin natin ngayon ay expanded element stiffness matrices. So, we have 7 elements. So, gagawa tayo ng 7 expanded matrices. So, this is for element 1. And then, you have displacements D1, D2, D3, D4, 5, 6, 7. So, gawin ko lang ito na subscript. Yan. Para bababa siya. Then, this is D2. Subscript ko rin yan. So, walang pinagkaiba ito sa mga ginawa natin kanina na yan. D3, 4, 5, 6. Kung gusto mo, pwede mo ring i-subscript yan. Palitin mo lang yung font number, yung font size niya. Okay? So, pwede rin yan. Next, this is D3, D4, D5, D6, D7. Okay, so palitan ko lang yung mga subscript niyan. Yan. And then this is, copy ko lang ito. This becomes F1, F2, F3, F4, F5, F6, F7. Oops, sorry. Then, lagyan ko rin dito sa taas para hindi ako mawala. This is D1, D2. I-subscript ko na rin yan para magandang tingnan. Okay. 2, 3, 4, 5, 6, 7. Yan. Okay. And then for element 2, I will just copy this, paste it here, palitan ko to ng 2, copy ko yan, then element 3, 4, 5, 6, and then element 7. Then 6, yan. 5, tapos this is element 4, then element 3, then element 2. Okay, so balik tayo ngayon sa element 1. Kokopyahin natin yung contents ni element 1. Palitin ko lang muna to sandali. Ayan. Okay, tapos nasan si element 1? Ito. Kopyahin ko lang ito, no? Yan. So, copy. This is element 1, okay? Copy ko yan. Importante makopya mo yung numbers na yan, tsaka itong displacements na yan, ano? So, copy. Then, paste ko lang dito sa tabi. Paste special. Oops. Ulitin ko, no? Copy ko yan. Paste ko dito. Ayan muna, paste. Tapos, right click ko dyan. Ang purpose nun is kokopyahan nyo yung mga borders. And then, i-right click ko yan and then paste special naman. Ang purpose nito, yung mga exact values. Take note na hindi na ito links, hindi na ito equations, mga values na yan. Tapos, dito naman ngayon, susundan mo rin yung numbering nito. So, this is D1, this is D2, D3, and then D4. Ngayon, yung 31.5, saan yan pupunta? Dito sa D1, D1. Okay? Kaya dyan mo siya itatype. So, 31.5. Next. Itong negative 31.5 nasa column D3 tsaka row D1. Okay, yan. D3 tsaka D1. So, dito, D3 tsaka column D3 tsaka row D1. So, dito mo itatype si negative 31.5. Yan. Okay, ba't kaya nag-sharp? Nag-hashtag yan kasi maliit yung space. Yan. So, palagyan natin yan. Next, eto naman, nasa column D1 tsaka row D3. Okay? Ayan. Column D1 and then row D3. So, dito tayo sa column D1 tsaka row D3. And that is negative 31.5. Kapag may parenthesis na ganyan, ibig sabihin yan ay negative. Next, you have here 31.5 nasa column D3 tsaka row D3. Yan. So, D3, column D3, tsaka row D3. So, this is 31.5. Okay, now let's go to element 2. Yan. So, again, I will copy this. Yan na lang. paste it here, Control V. Tapos, balik ko dyan, first, dito sa first corner, right click and then paste special. Yan. Tapos, copy mo yung displacements dito. Then, this is wala. Tapos, this is D5 and then this is D6. Okay. So, etong 31.5 saan natin siya ilalagay? Walang katapat yan na column. Same as this. Wala ring katapat na column numbering. So, walang silbi yan. Okay? How about this? Negative 31.5. Meron siyang katapat, pero wala siyang katapat na row. So, wala ring silbi ito. Okay? So, ang merong silbi lang na mailalagay natin dito ay yan lang. Meron siyang katapat na column D5. Take note. Nandun siya kay D5 tsaka kay row D5. So, dito natin siya ilalagay. Yan. 31.5. Now, let's go to element number 3. Copy. Paste natin dito. Next is paste values. And then, copy mo rin yan, D5, 6, 7. So, this is D5, D6, D7, and then, wala. So, maglalagay tayo ngayon kay column D5 dito. Then, row D5. So, this is column D5 and then here. Yan. Okay. So, that is 31.5. Next, ito naman, column D7, row 5. Column D7, row 5 dito. So, that is negative 31.5. Here naman, this is column D5, row 7. So, column D5, and then, row 7. Yan. So, dyan natin ilalagay si negative 31.5. Kapag parenthesis, that means it's a negative. And then, we have column 7 and row 7, that is positive 31.5. So, this is for element 3. Next, element 4. Ayan, sa element 4. Paste. Then paste special. This is column D1, D2, D5, and then D6. So, here we have 7.88. Okay. This time, be careful, ano? Nagkataon na yung mga 31.5 dito sa elements 1, 2, 3, they are exact na 31.5. Okay? Pero pag dito na kay element 4, yung 7.88 is not 7.88 lang. Meron siyang 7.875 something, something, something. So, you just copy this, then paste mo yung values dyan. Okay? Para makakopy niya yung buong decimal places. Next, you have negative 13.64. So, I will copy this. Remember na ang ginawa natin dito kanina ay paste values, di ba? So, hindi na yan equations. These are numbers. Okay? With decimal places. So, I will copy this. 13.64. Ipe-paste ko siya ngayon kay D2, column D2, row 1. Ayan, dito. Paste. Next, D5, dito naman. Yan. Tapos, D6. Copy ko lang dito. That's it. Remember na lahat yan na kay row D1. Ayun, D1. Okay, so next, dito naman. Dito siya kay column D1. Then, 23.63 kay column D2. Then 13.64 kay column D5. Then 23.63 kay column D6. Next, yung negative 7.88 kay column D1. Pero dito siya kay row 5. Okay, so column D1, row 5. Ayan. Kita mo yung subscript na yan, ha? Yan. Just, diyan ko siya ipe-paste. Tapos, 13.64. Then, 7.88. So, that is D5 and D6. Tapos, ito naman, 13.64. Dito siya. Then this is negative 13.64 and 23.63. Ayan siya. Oops! Nakopy pati yung margins. Okay, so I will undo. Control C. Paste values. Ito naman. Control C. Paste values. Next is element 5, 6, and 7. Tatlo na lang. Kaya to, no? So this is for a matrix of 7 elements with 7 displacements. Okay? Kung minsan, pwede kang mag-assemble or meron ding mga trusses na hindi parehas ang displacements tsaka number of elements. Meron ganong cases. So let's go to element 5. Ayan, take note, this is D7. Column D7, ano? Oops. Then, D4. Tapos, dito siya sa row D7. Yan. So, this is column D7, then row D7. So, ito. Then, element 6. So, ito, magkakasunod. 3, 4, 5, 6. Yan. Oops! Something's wrong. Mali. Dapat, pinis ko to dito sa row 3. Yan. Pinis ko dito siya sa row 1. Mali. Yan. Be careful. Ano? Then, element 7. So, blanco, blanco, then D1 and then D2. So, ito lang ang kukupihin natin. Nandito yan. Okay, now let us assemble now or let's check first bawat element stiffness matrix. Ang dito sa part 3, ang element stiffness matrix is always a square matrix. Okay? Ang ibig sabihin ng square matrix ay, aside from square, it is always a symmetrical matrix. Ang ibig sabihin niyan, yung nasa upper triangle, okay, ito, yung upper triangle, is symmetrical with the lower triangle. Kagaya, 31.5 negative, ito, 31.5 negative. Yan. Symmetrical yan. Look at this element 4. Ito yung diagonal, ano? Yung upper triangle, okay, is symmetrical with the lower triangle. Ibig sabihin, parang mirror siya. Yung upper triangle, mirror niya yung lower triangle. So, this is 13.64. 13.64 negative din yan. 7.88 negative, 7.88 negative, 13.64 positive, 13.64 positive. See? Yan ang characteristic ng element stiffness matrix. Lahat yan ay symmetric matrix. Okay? Ngayon, kung merong isang number dyan na merong isang element matrix dyan na nagkamali, hindi siya symmetrical, mali na lahat yan. Okay? Ganon din dito sa expanded element stiffness matrix. Symmetrical pa rin yan. Look at this. So, ito yung main diagonal natin. This is 31.5 negative. Symmetrical yan. Ano? Ganon din dito. Ito yung ating main diagonal. The upper triangle are all zeros. The lower triangle are also all zeros. See? At element 4, ito yung ating main, or this is our diagonal. See? This is negative 23.63. This is also negative 23.63. Okay, ito, nagkataon lang na parenthesis yan. Ito, may negative dun. Pwede mo yung gawing general. See? Yan. Wala na yung kanilang parenthesis. Dito lang sa format nagkaiba. Okay. Kagaya yung nagawa ko kanina dito. Ito yata na ilagay ko dyan sa taas eh. Parang something like this yung ginawa ko kanina. Ganyan. Yan, mali na yan. Hindi na yan symmetric matrix. Okay? So dyan ako na-alarma kanina. Okay? So that's one characteristic of element stiffness matrix. Ganon din yung expanded stiffness matrix. And then next is we will now assemble your global stiffness matrix. So ganito yun. Okay, this is now, ang ibig sabihin nito ay F is equal to K D. Yan, okay? Or F times KD. Yan. Or in K, ito yung mga direction cosines multiplied by AE all over L. Okay? And then D, this is your column vector matrix composed of your displacements. And then F is your column matrix composed of your external forces or loads. And then this is also similar to this is K, sorry. F, this is K times D. This is also similar to Hooke's law. Wherein your force is equal to your stiffness multiplied by the displacement. Okay? Yung displacement na yan, yan yung net extension. Something like that. Okay, so binalik ko lang yon. This is D1, D2, D3, D4, D5, D6, D7. So, i-add natin lahat from element 1 to element 7. Lahat ng D1, D1. Yan. 31.5 plus element 2 plus element 3 plus element 4 plus element 5 plus element 6 plus element 7, and then I will now press enter. Okay, tapos all I have to do now is to copy this and then paste ko lang dyan. Oops, undo. Right click. Click mo itong formula. Yan. Or i-highlight mo yan. Right click. Paste formulas. Okay? So, ibig sabihin yan, if you will click itong nasa last, ang sinam niya, lahat ng D7, D1, no? Yan. This is for element 7, element 6, element 5, element 4, 3, 2, 1. So, parang shortcut lang natin. Instead na gagawa tayo ng equal to this plus this plus this plus this plus this plus this plus that. Okay? Yeah. Next is I will simply copy that. Paste ko na siya dito. Yan, lahat. Tapos right click and then paste formula. Yan ang ating global stiffness matrix. Ngayon, i-highlight ko itong main or yung diagonal. Isa lang naman ng diagonal. Notice na itong upper triangle niya is again symmetrical with this lower triangle. Okay? So this is 0, this is 0, 13.64, 13.64, negative 7, negative 7. Etong part 4, that is now your global, that is known as your global stiffness matrix. It is simply the sum of all your element stiffness matrices. Pero take note na itong element, lahat ng element matrices natin, inassemble natin siya sa global matrix. Ibig sabihin ng global, nakalagay na dyan yung D1, D2, D3, D4, D5, D6, D7. Okay? Element 1, nakalagay na siya sa 7 by 7 na matrix. Para pagdating mo dito sa global, madali na lang siyang mag-add. And then next, ilalagay natin yung mga external forces na. Yung F1, F2, F3, F4, F5, F6, F7. So, dito natin siya ilalagay. Okay. Copy ko lang ito. Yan. But what is F1, F2, 3, 4, 5, 6, 7? So, balik tayo dito sa ating figure. Okay? Yan. Remember na gumawa tayo ng numbering ng nodes tsaka numbering ng freedom. Also, yung numbering ng forces is the same with the numbering of freedom, di ba? Kapag D1, ang katapat niya na force is F1. Kapag D4, ang katapat niya na force ay F4. Okay, yan yung ginawa natin dito sa part 3, di ba? D1, F1, D2, F2, D7, you have F7. So, kokopyahin natin ito, or this will be my reference. Paste it here. Okay. So, yung 100 kilonewton na yan, ano ang katapat niya na displacement? It is D2. So, ano ang force ni D2? Siyempre, siya si F2. And, yan ang i-maintain natin. So, markan ko lang yan ng red. Okay? Or, i-bold ko lang yan. Next, etong 50. Remember that we only have two forces here. Si 100 tsaka si 50. Ngayon, si 50, ano ang katapat niya na displacement? Si D3. Okay? Or that is F3. So, yan ang aking i-bold. The rest is wala na. So, papatayin ko niyan. F1, wala siyang laman. F4, wala. F5, F6, F7, wala. Or they are all simply 0. Okay? Kasi walang forces. Or, delete mo na lang siya. Now, what is F2? The value here is negative 100. Okay? Negative in the sense na it is downwards. Ngayon, si F3, it is positive 50. Yan. Okay, so, that is now our global stiffness matrix. Na-assemble na natin siya. Part 4. Yung ating global stiffness matrix, which is this, is in this form, no? F is equal to KD. Okay? For in F, this is your force matrix. Tapos yung K, ito yung stiffness matrix, ito. And then D, this is the displacement matrix. Also, your F, your force matrix is a column matrix or vector matrix. Ibig sabihin, isang column lang yan. Wala siyang, it is composed of a single column with several rows. Tapos, itong K or yung stiffness matrix, ito yon. This is a square symmetric matrix. Well, this is the most important, one of the most important part dito pinangalanan yung method, no? And then yung D, that is the displacement matrix, or it is also a column vector matrix. It is composed of only one column. All in all, this is refers similar to Hooke's law. So kapag the force is the product of the stiffness of the member and then the neck extension. Okay? And then this is in matrix form. Yang force na yan, ito yon, given na yan, di ba? It is composed of 0, 1, negative 100, 50, then 0, 0, 0. Tapos, yung K, ito yan. Tapos yung displacement, these are unknowns. Ngayon, pwede nating i-rewrite ito, something like this. I-write ko siya sa baba. Okay, ito, ilagay ko dito. Yan. Pares lang yan, no? And then, take note na yung F is given, K meron na, so D is unknown. Ngayon, itra-transpose natin yan. So, D now happens to be, the displacement now is equal to force divided by K. Okay? Yan. So, very simple. Displacement is equal to force divided by K. Yung K, i-transpose lang natin dito sa kabila. But take note that K is the inverse. So, we can rewrite this as D is equal to K raised to negative 1 times F. Okay, so superscript natin yan. Yan. Okay, so displacement is equal to K inverse multiplied by the force. Ngayon, gagawa tayo ng sample linear system, ano? Linear system is simply the number of linear system solving a number of unknowns with the same number of equations. Okay. So, number of unknowns equal to number of equations. Okay? So, gagawa tayo ng example. Let's say, 2x plus 3y minus 4z is equal to something. Okay? Tapos, let's say, 3x minus 2y minus z is equal to something. Tapos, x plus y plus z is equal to something. And this is 8, this is 4, then this is 6. Okay, so this is equation 1. This is equation 2. Then this is equation number 3. Okay. Sa equation 1, you have 2x plus 3y minus 4z is equal to 8. Equation 2, you have 3x minus 2y minus 4z is equal to 4. Equation 3, you have x plus y plus z is equal to 6. Okay, i-rewrite natin yan similar dito. Okay? So, let's say this is f and then kd. So, ito yung, let's say, ito yung ating unknowns. Ang unknowns natin, you have x, y, and z. And then, these are your number of equations. Okay? So, number of equations, you have 3. Number of unknowns is also 3. Number of unknowns is 3. Number of equations, you have 3. Okay? Ang unknowns natin, you have x, y, and z. Okay? So, you have f is equal to, k times d. Ngayon, yung f natin, that would be your eight, tapos 4, tsaka 6. Ayan yon. Tapos, yung k natin, yan yung coefficients. Okay, so that is 2, tapos 3, and then negative 4. Tanggalin ko nga muna yan. Tapos, ang ating unknown, you have x, y, and z. Okay? Tapos, sa second row, this is equation 2. The coefficients are, you have 3, tapos negative 2, and then negative 1. So, yung 3, negative 2, and negative 1, yan yung equations or yung coefficients ng equation 2. Okay, so 3, ayan, tapos negative 2, ayan, and then, para kay z, you have negative 1. Tapos, sa third equation, you have x, y, z, 1, 1, 1. Okay, so that's it. Ngayon, going back here, alam na natin si f, eto, meron na tayong k, matrix, ayan. Ang unknown natin ay si d. Okay, so, to solve for d is equal to f divided by k. Diba? Ganyan lang kasimple. F divided by k. Or, simply put, d is equal to k inverse multiplied by f. Okay? This is k raised to the negative 1. Okay? Or, pwede mo ring sabihin na d is equal to 1 divided by k multiplied by F. Yan. Yan din yun. Ngayon, sosolvin na natin yung K inverse. Okay, so K inverse now is something like this. Dito natin siya dadalhin. Equal to M inverse, then open parenthesis, i-highlight mo yan, then close parenthesis, and then enter. Okay? Tapos, i-click mo yan, and then drag hanggang dito sa baba. Yung 3x3. Yan yung destination cells. Or dyan pupunta yung inverse. Then you press F2. And then you press Control, hold, and then Shift, hold, and then press Enter. Then release. Sabay-sabay silang tatlo. Yan. Okay? Ulitin ko, no? Ang i-inverse natin, eto, yan, okay? Yang naka-red. I-click, dito natin siya dadalhin, ano? I-click mo yan ngayon. So, equal to, and then, i-type M inverse. Ang ibig sabihin niyang M inverse is simply matrix inverse. Open parenthesis. Now, you click your stiffnesses, or your constants, your elements. Then, close parenthesis, and then, enter. After that, click this and then drag hanggang dito sa baba. Yan, 3x3 yan, ano? Then, i-press F2, then Control, press, and then Shift, hold, and then Enter. Then, release silang tatlo ng sabay-sabay. Next is, so meron na tayong K inverse. So, solvein na natin ngayon si D, si X, Y, and Z, okay? Let's say, dito natin siya dadalhin. Yan. And this is your D matrix, or your set of unknowns. Now, this would be equal to, yan, K inverse. No. This is equal to M mult, open parenthesis, okay, then i-highlight mo yung K inverse, lahat yan, comma, tapos yung F matrix, yan, yan, and then close parenthesis, then you press enter. Next is, click mo yan and then drag hanggang dyan sa baba, then i-press F2, then, Control, Shift, Enter, sabay-sabay. See? That is now your set of unknowns, displacements, or 3, 2, 1. Okay? So, ganun lang kasimple. Ulitin ko, ano? I will press Enter. I will press equal sign, and then M mult. M mult means matrix multiplication. Open parenthesis, you click your inverse, comma, then your force, then close, enter, then you click and then drag, yan yung mga pupuntahan niya or destination cells, then you press F2, then Control, Shift, Enter. Yan. So, ibig sabihin yan, X is equal to 3, Y is equal to 2, and then Z is equal to 1. Ngayon, i-check natin. Remember, X is equal to 3, Y is equal to 2, Z is equal to 1. Isa-substitute natin yan dito. Okay? Dapat, equation 1 would be equal to 8. Okay? So, equal to 2 times what is X? It is 3. Okay, plus 3 times what is Y? It is 2. Okay. Oops, sorry. Dito na lang. 2 times x is equal to 3 plus 3 times y, which is 2, minus 4 times z, which is 1. Then, enter. See? It is 8. So, tama yung equation 1 natin. Tama yung x, y, z. Now, check natin. Substitute natin si x, y, z dito kay equation 2. Okay? So, that is 3 times 3 minus 2 times 2 minus z, which is 1. So, 4. Correct. Then, next, third equation, we substitute x, y, z. You have 3 plus y, which is 2, plus z, which is 1. Yan. So, 8, 4, 6. Okay? So, yan ang pag-solve ng linear system. So, we will apply this using inverse method. Okay? By the way, ang tawag dito is inverse method. Pag-solve ng unknown using inverse method. We will apply this to solve for the displacements D1, 2, 3, 4, 5, 6. Okay, let's continue. Delete ko lang ito. And then, ayan. Let's say, ito. So, we are now in part 5. This is solving for the displacements. But first, dapat kunin natin yung inverse ng ating stiffness matrix, which is this. So, this is a 7 by 7 square matrix. Ito ngayon yung destination niya. It is the number of displacements is the number of your inverse. Okay, so this is 7 columns, okay, by 7 rows pababa. So 7, 1, 2, 3, 4, 5, 6, 7, and then 7 pababa. 1, 2, 3, 4, 5, 6, 7. Yan yun. And then, punta ka dito sa first cell, you type there M inverse, open parenthesis, then you highlight this is our K, then close parenthesis, enter. Tapos, i-highlight mo yung destination niya, F2, Control, Shift, Enter. Okay? And then remember that force is equal to K times D. Okay? Force is equal to K times D. Okay? Ito yun. F is equal to K times D. Tanggalin ko na tong X. Yung force, ito yun. Yung K, ito yon. Tapos yung D natin, yan yung unknowns. Okay? So, F is known, K is known, D is unknown. So, D is equal to F divided by K. Okay? Or, D is equal to K inverse, or 1 divided by K multiplied by F. Ganyan din yon. Or D is equal to K inverse multiplied by F. Yan. Isusuperscript natin yung yan. Clinic ko lang si superscript. Yan. Pero, ang nasolve natin ngayon, yung K inverse, which is this. Okay? So, ibig sabihin yan, ito ang gagawin natin. Yan. So, gagawa tayo ng column matrix composed of 7 unknowns. 1, 2, 3, 4, 5, 6, 7. Yan. So this is your D matrix. Okay? Or ito yung ating unknowns na D1, D2, D3, D4, D5, D6, D7. Yan ang unknowns natin. Okay. So, dyan sa first column, this is equal to M mult. And then, highlight natin si K inverse. Then, comma, highlight natin si force, which is this. Highlight mo yung buong yan, no? Then, close parenthesis. Then, you press enter. Next is, you highlight ito, yung first hanggang dyan sa baba. You press F2 and then Control Shift Enter. Yan ang ating displacements ngayon. This is in terms of millimeter. Okay, so balik tayo dito. Yan, kopyahin ko to. Okay? Paste ko dyan. Ang ibig sabihin yan, si D1, this is in terms of millimeter, no? Si D1, si point 2, nag-move siya ng 3.79 mm to the right. Tapos, si D2, nag-move siya ng negative 4.44 pababa. Yan, ang ibig sabihin nun. Tapos, D3, D4, ito naman. Si point 3, nag-move siya ng 3.66 mm to the right. Nag-move siya ng 1.83 pababa. Ayan, negative. Tapos, si D5 and 6, ayan, nag-move siya ng 2.57 mm to the right. Nag-move siya ng 3.17 mm pababa, negative. And finally, si D7, nag-move siya ng 3.42 mm to the right. Okay, so yan ang ibig sabihin nun. Your displacements is in millimeter. Next, ang sosolvin natin, you have the member axial forces. So that is part 6. Yan, okay? So part 6, member axial forces. Okay, so babalik tayo dito sa ating lecture. Ito, no? F is equal to AE times the quantity U2 minus U1 times L plus V2 minus V1 times M. Yan lang yun. Yan. Okay? So, this is from our lecture. Oops. Yan. So, ito ang ating pinaka-main equation to get your member axial force. Yung F na yan. Take note na yung F na yan, that is already your axial force F. So, na ba yun? Yan. Yung nandito sa member. Dahil meron ka ng net extensions D1 tsaka D2. By the way, yung net extensions D1, D2, yan na yung based on U1, V1, tsaka U2, V2. Okay? So, kailangan natin ngayon yung AE all over L, tapos U2, U1, tapos L, tsaka yung V2, V1, tsaka yung M. Ano yan ngayon? So, yan ang gagawa natin ng spreadsheet. Okay, so ito ang ating spreadsheet. So this is element. This is element. We have 7 elements, no? 1, 2, 3, 4, 5, 6, 7 elements. And then you have AE all over L in terms of kilonewton per millimeter. Yan ang unit. And then the displacements, U1, V1, U2, V2. This is also in terms of millimeter. And finally, your force, which happens to be this equation, it is in terms of kilonewton. And then you have the direction cosines L and M. So this is unitless. So block lang natin yan. Yan. So, etong AE all over L tsaka yung LM, saan natin kukunin yan? Dito sa ating part 1, part 2. Yan. Yan. See? Ito yun. So, 31.5 tsaka yung L and M. So, I will just copy this. Paste it here. Values, ano? And then yung LM, ito, copy. I will copy this. Yan yung direction cosines, ano? Then, paste it here. Values. So, ang ginagawa natin ngayon is, this is parts 4, 5, and 6. Ganun ba yun? This is part 4 pala. So, part 4. Nahilo na ako. This is global stiffness matrix. Then, part 5 and 6. Part 4. This is parts 4 to 6. Okay. Next, ano ngayon yung U1, V1, U2, V2? So, balik tayo sa figures natin. So, yan. Balik tayo dito. So, I will copy this. Okay. Paste ko dito. Ito pala yung actually, ano? Kay element 1, ang kanyang U1 is D1 and D2. Yan. Okay. So, D1, then D2. Tapos, you have D3 and D4. Kanyang U2 ay D3 tsaka D4. Tapos, kay element 2, ito, okay? This involves now node 1 and node 4. Sa kanyang node 1, wala. Tapos, dito sa node 4, you have D5 and then D6. So, this is D5 and then D6. Next, kay element 3, you have nodes 4 and 5. So, you have, kay node 4, ang kanyang displacement, you have D5 and D6. Tapos, kay node 5, you have D7. Ang vertical niya, wala. And then, kay element 4, you have node 2 and node 4. Kay node 2, you have D1 and D2. Okay, D1 and D2. So, dito tayo kay element 4, ano? Medyo nakakahilo na. Kay node 4, you have D5 and D6. And then, kay element 5, you have node 3 and node 5. Kay node 3, you have D3 and D4. Okay? And then for for node 5, you have D7 only. And then node 6, you have element 6, you have node 3 and 4. Kay node 3, you have D3 and D4. Oops. D3 and D4. Tapos, node 4, you have D5 and D6. Okay? So, D5 and D6. Finally, element 7, you have 1 and 2. Nodes 1 and node 2. So, kay node 1, wala. And then node 2, you have D1 and D2. Okay? So, remember that. Next is para hindi tayo mawala. I will just copy this. Paste ko lang muna dito sa baba. Okay? So, para hindi mawala ito. Importante yan, ano? Yung D1, D2, D3, yung mga displacements na yan. Now, as a check, paano natin malalaman yung mga numbers na yan? Okay? Balik tayo dito sa part 3. Okay? Remember na kay element 1, ito, si element 1, you have D1, 2, 3, 4. Yan yun. If you will write here at the top, this is D1, D2, D3, D4. Okay? Dito naman kay element 2, this is blank, blank, 5 and 6. So, this is blank, blank, D5, D6. Ayan yun. Okay, punta tayo kay element 1. So, this is D1, 2, 3, 4. Ano? Kay element 1, yan. 1, 2, 3, 4. Kay element 2, 5 and 6 lang. Yan yun. Kay element 3, you have here D5, D6, and then D7, and then wala. Yan ang kukopyahin natin. Kay element 3, yan, see? D5, D6, D7, wala. Yan, okay? And then kay element 4, you have, dito tayo, balik, D1, D2, D5, and then D6. Pwede mo nang i-copy yan, which happens to be this. 1, 2, 5, 6. Okay? Next, let's check now, D5, 3, 4, 7, ano? Ay, kay element 5, you have D3, D4, D7. So, element 5, ayan. Sundan lang natin yan. You have D3, D4, and then D7. Okay? And then, element 6, 3, 4, 5, 6. Ayan, you have here D3, D4, D5, D6. Sinundan ko lang ito. And finally, element 7, you have blank, blank, D1, D2. Element 7, you have blank, blank, D1, D2. So, I copied this, paste here. Yan. And then, ngayon, yung mga numbers na ito, ilalagay na natin yan. Okay? So, si D1, I will copy this. Pe-paste ko dito kay D1. Values. Ayan. 3.79. Lahat ng D1 gagawin kong 3.79. Ayan. Okay, next. Lahat ng D2 gagawin kong negative 4.44. Lahat ng D2. Okay? Ayan. Tapos next, lahat ng D3, gagawin kong 3.66. Paste values. Ayan. Lahat ng D3. Tapos next, lahat ng D4, gagawin kong negative 1.83. Nasaan si D4? Ayan. Next, si D5, gawin kong 2.57. Ayan. D5, eto. Ayan. And then, si D6, negative 3.17. And finally, si D7, gagawin kong 3.42. Yan. Oops! Meron pang naiiwang D5. Yan. Okay, so let's check. Wala nang naiwan na D. Wala na. Next, syempre, yung mga blanco, pwede mong gawing 0 lang yan. Okay? Or, tanggalin mo na yung laman. Next, we now solve for F. Finally, susundan natin ito. Okay? So, first, we will do U2 minus U1 equal to U2 minus U1, ito, times L. Nasaan si L? Ayun. Okay. And then, oops, plus V2 minus V1. Nasaan si V2? Ay. Yan. Ano ka lang muna. Yan. Align left. Yan. Dito na tayo. Plus V2 minus V1. Plus open parenthesis. Nasaan si V2? Ito. Click ko yan. Minus V1. Nasaan si V1? Ito. And then close parenthesis. Times M. Nasaan si M? Ayun. 0. And then dito sa umpisa, ilalagay ko si tapos open parenthesis, and then dun sa dulo niya gagawan ko ng close parenthesis. Yan. Then dito sa umpisa, lalagay ko dito si AE all over L. Ayan. Multiplied by. So that's it. That is my first axial force for element 1. So I will copy this. Paste, 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 paste. Okay, so ito yung ating final forces. So that means for element 1, meron siyang 3.868. Yan. What is this? Compression or tension? For element 2, it is positive, 80.8. Is this compression or tension? Kapag, if you will look here, 2 and 3, obviously, magiging tension forces yan. Ano? Ibig sabihin, binabanat nag-elongate tong member na yan. So, kapag positive, that is tension. Okay? So, lahat ng positive magiging tension. Lahat ng negative magiging compression. Yan. So, I will reduce this to 2 decimal places. Negative 3.87, 80.8, 26.93, minus 53.87, 53.87, negative 61.6 compression. Now, how can we check if our manual solution is correct? So, pwede nating gawin ito sa STAAD. Okay? So, this is manual solution, and then dito gagawa tayo ng STAAD output. Kung magkaparehas yan, okay, then our manual solution is correct. Take note na itong stiffness matrix method, this is, as I've said before, this is applicable to both determinate and indeterminate. Kapag determinate, usually nasa dalawang supports lang yan. Kapag ka indeterminate, maraming supports, 2 or more. Tapos, pwede rin yung compound truss, ibig sabihin, applicable yung dalawang members, nag-cross. Okay, magkapatong yung dalawang members, pero hindi siya nag-intersect. Pwede yun. Or, pwede rin yung trusses to the pin-jointed structures na merong square sa loob. Applicable yun. As long as yung mga stability conditions mo, compatibility equations, nasa-satisfy yun. Yan ang stiffness matrix method. Also, this is for 2D or X and Y. Applicable din ito sa space. Ibig sabihin, meron ka ng X, Y, tsaka Z. So, kapag meron ng Z, meron ka ng U1, V1, U2, V2, U3, tsaka V3 displacements. Okay, so our next lecture would be yung pag-verify using STAAD. Okay guys, so that's it for now. Merong continuation ito using STAAD. So thank you for listening.